Latency metrics play a critical role in evaluating the performance of your application and services. By observing P90, P95 and P99 latencies, you can identify potential bottlenecks, optimize user experience and ensure that your system achieves high performance of the majority of users. In this video, we are going to look at what is P99, 95 and 90 latencies, how do they relate with the median latency. We are also going to look at the API SLA agreements and why do we even need a latency metrics for these APIs. So let's get started. Imagine we have an orchestrator API service which is connected to different microservices or third-party systems which perform specific feature operations. Now for every service, including the orchestrator API, a latency must be calculated so that we know that this particular API or service is going to take a particular period of time to serve. P90 latency signifies that 90% of requests are completed within the given latency value, while the remaining 10% took longer. P95 latency reveals that 95% of requests fall below the specific threshold, and this metric gives you additional insights into user experience, allowing you to cater to a wider audience. Similarly, the P99 metric indicates that 99% of requests are completed within the recorded latency, enabling you to identify problems that only affect a small percentage of users. Notice we are talking about P90, 95 and 99 percentiles because there cannot be a P100. The percentile value is supposed to be greater than 100% of the values, including the value. For example, in a sample set of 10,000 distinct values, the highest value is greater than 9,999 other values. Hence P99.99 but not P100. In other words, if you are the tallest person in a room of 20 people, you are not taller than 100% of the people. Now going back to P99, for a particular microservice, if the latency value is 100 milliseconds, this means there are going to be 99 requests which are going to be less than 100 milliseconds, and there is only one request which is greater than 100. In other words, it indicates the time within which the vast majority of requests are completed, and only 1% of the requests experience higher latencies. For example, let's consider this microservice that serves HTTP requests. Over a period of time, it processes various requests and their response times are recorded. Now, let's say we have the following response times for 100 HTTP requests in milliseconds. To calculate the P99 latency, we first need to sort the data set in ascending order. And next, we determine the index position of the 99th percentile. 99% of 100 requests would be 100 into 0.99, which is 99. So the index position representing the 99th percentile is 99. And the value at the 99th index position is 99 milliseconds. So in this example, the P99 latency for the 100 HTTP requests is 99 milliseconds. This means that 99% of the requests received a response within 99 milliseconds, while 1% of the requests took longer than that. Similarly, for P95, we determine the index position of the 95th percentile from the sorted dataset. 95% of 100 requests would be 95. And so the index position representing the 95th percentile here is also 95. The value at the 95th index position is 95 milliseconds. And so in this example, the P95 latency for 100 HTTP requests is also 95 milliseconds. This means that 95% of the requests received a response time within 95 milliseconds, while 5% of the requests took longer than that. Just like P99, P95 is used to understand the latency distribution of a system and identify performance outliers. Monitoring and optimizing P95 latency can help ensure a consistently positive user experience for the majority of users. P90 latency is often used to measure the performance of a system for the majority of users. It represents the value below which 90% of the measured latencies fall. And it is useful for understanding the performance experienced by most users, leaving out only the top 10% of outliers, and it helps identify typical response times and can be an indicator of how responsive the system is for the majority of users. The median provides a measure of the overall central tendency of the data. And to calculate the median latency of a dataset, you need to sort the data in ascending order and then find the middle value. If the dataset has an odd number of data points, the median will be the middle value. If the dataset has an even number of data points, the median will be the average of the two middle values. Now this median represents the middle value that separates the lower 50% of response times from the upper 50%. P99, however, considers the value below which 99% of the data falls, providing a better understanding of the worst case scenarios and areas of improvement. The median latency only considers the middle value in the dataset and is not sensitive to outliers or extreme values. Median latency gives an insight into the central tendency of the data, which might not be useful for identifying worst-case scenarios. In critical systems, understanding worst-case performance is crucial to ensure a high level of responsiveness for as many users as possible. P99, for instance, provides a better view of worst-case performance, making it more valuable in such situations. Which is why P90, P95, and P99 percentiles are essential metrics to assess the performance and responsiveness of a system in different scenarios. They help to evaluate the experience of majority of users, identify typical response times, and understand the impact of outliers on performance. While the median latency provides a measure of central tendency, percentiles offer a more nuanced view of the distribution and are valuable for performance analysis and optimization. P90, P95, and P99 focus on the tail end of the latency distribution, which is particularly important for evaluating user experience. By monitoring and optimizing these percentiles, system administrators and developers can prioritize improving the experience for the majority of users, and which is why P90, 95, and 99 have become widely accepted as standard latency metrics in various industries, including web services, cloud computing, and network performance. Amazon Web Services is one of the leading cloud computing provider, which includes P90, P95, and 99 in their CloudWatch service for monitoring various resources and services.